Hello everyone and welcome to a new episode of the Icaerus podcast series. Icaerus is a European Union funded project aiming to explore how drones can serve multiple purposes in agriculture, forestry and rural areas across Europe. I am Alexia Mastora, Communications Manager at Reframe Food, a non-profit organization aiming to transform the agri-food sector through innovation and technology. Today we are delighted to welcome Mr. Vasileios Psiroukis. Vasileios is an agricultural engineer and a senior research associate at the Agricultural University of Athens. Hello, Vasily, and thank you for being here with us.
Hello, Alexia, and thank you for having me.
Okay, let's start with our first question. Let's introduce the second use case of the Icaerus project to our audience. Why are drones being considered as a tool for spraying?
Yes. So there is this new technology, let's say, the spraying drones, that have been around for well over a decade, almost at this point. And they have been theoretically, let's say, established as a novel solution that offers some advantages and some benefits compared to conventional spraying applications. So our use case focuses to assess how we can evaluate the efficiency and in general the performance and the environmental impact of this new novel technology. And this can allow us to give, let's say, recommendations or provide concrete data on whether this is an appropriate, let's say, replacement or tool to partially or fully replace the conventional applications that are terrestrial sprayers.
Okay, that is a great introduction. Let's move to our next question. Are regulations for drone spraying uniform across the EU or do they vary significantly? And what about Greece?
Yes, so there are no major differences between Greece and the EU, and that's because all member states have adopted the same regulatory framework that has been published by EASA, the European Airspace Regulatory Authority. So to this end, when spraying drones were introduced, they were automatically considered as aerial spraying. And area spraying under this framework is prohibited for crop protection applications. So this is the major challenge of our use case, that we are dealing with a technology that has been proven effectively. However, it remains prohibited because it falls under a prohibited category of aerial spraying. And this is a focal point for our research. And this is the reason we have also direct contact with the market and crop protection product manufacturers, because it's very important that data are provided so that a regulatory shift can start from research and industry alongside each other, and then we can expect a prohibition lift in the following years.
That was very insightful and thank you for breaking it down so clearly. How do weather conditions, terrain and other environmental factors influence the effectiveness of drone spraying?
Yes. So first of all, let's start with terrain. One of the most, let's say, important advantages and benefits that spraying drones offer is that they can very easily traverse hard or high risk, let's say, areas that are normally difficult or very risky to traverse, to access with terrestrial vehicles, usually because the terrain is very stiff and there is a high risk of a terrestrial vehicle flipping over. So drones eliminate that. They have various sensors, so for example, active sensors like lidars that can very easily follow the terrain. And of course, they have no pilot on board, so there is no risk of a human injury. Now, for the weather parameters, this is a very important factor for all spraying applications, not only for drones. We have been conducting research on spraying applications and their efficacy for the last decade, and we have found that by far the most important parameter that affects displacement, so the amount of pesticide that gets transferred outside our target area, spray drift, is by far something that's very susceptible to wind. So wind speed should always be considered, and most importantly, wind direction, because we want to mitigate spray drift, we want to eliminate any potential displacement, and we want to keep as much of the application within our target area.
Thank you, that was very insightful. Thank you for sharing this. What kind of training or expertise is required for a farmer or operators to use drone spraying effectively?
Mm-hmm. So normally, drone, let's say, licensing is categorized based on the weight of the aircraft. Now, spraying drones usually belong to the heaviest category. They are aircraft that weigh more than 25 kilograms at takeoff, because of course they have a very large liquid payload. But nevertheless, because as we mentioned earlier, we talk about a machine, a flying machine, nevertheless, that carries liquid, and this liquid contains active substances. So by default, aerial spraying is considered a very high-risk application. So it usually falls under the special category as established by EASA. So it requires some additional steps, and this in turn requires the pilot, the operator, to know how to conduct various risk assessment steps and preparatory measurements before its application to ensure that everything goes smoothly and there are no, let's say, hazardous, steps or things that are not considered properly.
It is encouraging to see how focus on training and certification ensuring safety and proper operation. This builds real confidence in this approach. Can you give us an overview of the work being conducted in this use case?
Yes, of course. So we have, let's say, divided the use case into two different pillars. One is an extensive set of field trials that take place aiming to achieve high repeatability. So a lot of field trials to ensure that we manage to get a very accurate model of how the spraying operation takes place and how we can model it. So for these experiments, we do not use actual agrochemicals. We just use water and, in some occasions, for some specific measurements, color tracers, a common dye. And these are, let's say, the first half of the experiment. We have been conducting them for 3 years in an experimental vineyard that belongs to the Agricultural University of Athens. Now, for the other half, we actually move to efficacy trials. And in efficacy trials, first of all, we conduct them in collaboration with multinational crop protection companies that are brought along by our use case partner, the Hellenic Crop Protection Association. And in these trials, because we use actual agrochemicals, we need to obtain experimental permits in advance so that we can, let's say, create a detailed plan of how these operations will be carried. As we mentioned, it's a very high risk operation, right? Nobody knows what happens really, because there is very few research done, and this is the research that we carry out now. So the other half, we have identified 5 major crops of interest for the Greek agricultural sector, and we have started designing experimental plots, experimental designs for every specific crop and every specific application. So for example, fungicide applications, herbicide applications, anything that is of relevance for these crops, and we see how we can assess the efficacy of spraying drones compared to the conventional application methods, namely the terrestrial sprayers that are commonly used.
That sounds very thorough, and especially how you combining real-world trials with scientific analysis to push this forward. Let's move to our next question. Hellenic Crop Protection Association is one of Icaerus' partner, and its involvement means bringing real industry members to the table. How has this impacted your use case?
So our partner, Hellenic Crop Protection Association, is let's say a pillar of the use case, because they are the connection, the direct connection we have with the industry. As we mentioned, the multinational companies are brought together by HCPA, and it is HCPA who also leads the coordination of these efficacy trials, and also to allocate which, let's say, crop protection company, manufacturer company, takes up every specific crop, what type of products will be used, how the overall strategy for the application will be. Generally, the entire planning and logistics section of the efficacy trials falls under HCPA. And of course, as we mentioned, this is also our connection not only to the industry, but also to regulations. Because the CPA is very well positioned to establish connections with regulatory authorities, with public organization, non-profit organization. Pretty much everything under the umbrella of regulatory change, we can access it directly through our connections with HCPA.
That's great to hear. Field experts make a real impact, and their inputs are expanding the trial scope and relevance, if I may say. Let's move to a more technical question. What type of drones are being used for spraying, and what other components or technologies are required to make the system work effectively?
Mm-hmm. So first of all, the spraying drone itself is the primary component of the spraying applications, with all its relevant components. So for example, spraying drones, they might have modular parts. So for some applications, we might want to use different nozzle types, or we might want to change something on top of the aircraft, so this just changes respectively. So if we consider everything that is carried by the drone as one component, then the first component is the spraying drone itself. Now, because we mentioned that the environmental parameters are so important, it's always advised, and for research this is mandatory, that the environmental conditions are thoroughly monitored and recorded, because this is, as we mentioned, the number one factor that can create displacement and generally affect the end result, which is the application.
And by highlighting these technical issues, we concluded today's episode. Warm thank you, Vasileios, for joining us and sharing your insights.
Thank you very much for having me, Alexia.
And of course, heartfelt thanks to all of our audience members. For more Icaerus news, don't forget to subscribe to our newsletter and follow us on social media. Until the next time, let's fly towards a more sustainable future. Thank you very much.